In the spring of 1940, German bombers ruled the skies over Europe. Every Allied pilot climbing into a cockpit knew one terrible truth. The Luftwaffe was faster. They climbed quicker. They struck harder. British Hurricanes and Spitfires clawed for altitude while Messerschmitt fighters danced above them. American pilots training for war watched newsreels and wondered how they would ever compete, but the Germans had no idea that their advantage was already slipping away. Not because of a new engine, not because of a secret weapon, but because of a spinning piece of metal bolted to the front of every Allied aircraft. A device so revolutionary that it changed the physics of flight itself. The man who built it wasn't a general or a fighter ace. He was an engineer from Tennessee who spent 20 years being ignored, dismissed, and laughed at by an industry that thought propellers were simple. His name was Frank Caldwell, and by the time the world realized what he had done, Germany's air superiority was already dead. Frank Walker Caldwell was born in 1889 in Lookout Mountain, Tennessee. His father was a businessman and the mayor of Chattanooga. Young Frank grew up surrounded by the machinery of the industrial age, steam engines, dynamos, and the roar of factories turning raw iron into progress. But Frank wasn't interested in running a company. He wanted to understand how things moved. He wanted to calculate force, measure efficiency, and solve problems that others dismissed as impossible. In 1912, he graduated from the Massachusetts Institute of Technology with a degree in mechanical engineering. Aviation was still a circus act. The Wright brothers had flown less than a decade earlier. Most people saw airplanes as toys for daredevils, but Frank Caldwell saw something different. He saw a machine limited not by its engine, but by the wooden blades spinning in front of it. His final thesis at MIT carried a title that no one thought mattered: Investigation of Air Propellers. His professors told him to focus on real engineering. Bridges, turbines, railways. Propellers were just carved wood. There was nothing to investigate. Caldwell disagreed. He filled notebooks with calculations. He sketched blade angles, measured thrust coefficients, and studied how propellers interacted with moving air. While other engineers chased horsepower, Caldwell chased efficiency. And what he discovered disturbed him. The propeller was the most neglected component in aviation. Every aircraft designer obsessed over engines and wings. But the propeller, the only part that actually converted engine power into motion, was an afterthought. It was carved once, bolted on, and never changed. A propeller optimized for takeoff was terrible at cruising altitude. A propeller designed for high speed was useless for climbing. It was like driving a car stuck in one gear forever. Caldwell knew there had to be a better way. When the First World War erupted, Caldwell joined the United States Army Air Service. He became the chief engineer in the Propeller Research Department of the Engineering Division. It sounded important. It wasn't. The military treated propellers like lumber. They ordered them by the hundreds from furniture factories. If a blade cracked, you bolted on a new one. Caldwell tried to explain that propeller efficiency could improve aircraft performance by 30% or more. They nodded politely and ignored him. He proposed variable pitch designs, propellers that could change their blade angle in flight to match different speeds and altitudes. The reaction was unanimous. It was too complicated, too expensive, too fragile. And besides, who needs a propeller that changes? Just build a bigger engine. Caldwell left the army frustrated but not defeated. He spent the 1920s consulting, designing, and testing. He built whirl rigs to measure thrust. He mounted propellers on fixed stands and spun them at brutal speeds to measure endurance and efficiency. He became obsessed with one idea. The propeller wasn't just a component, it was the interface between engine power and aircraft performance. And that interface was criminally under-optimized. By 1929, he had refined his vision. He joined the Hamilton Standard Propeller Corporation in Connecticut as chief engineer. Finally, he had a laboratory, a budget, and a team, and he was ready to prove the aviation world wrong. The problem was simple to describe but brutal to solve. A fixed-pitch propeller is frozen at one angle. During takeoff, the engine screams at maximum RPM trying to push the aircraft forward. The propeller bites thin air and wastes energy. At cruising altitude, the same propeller becomes inefficient again. The blade angle is wrong for the thinner air and higher speed. Pilots were stuck. They could optimize for takeoff or for cruising, but never both. Caldwell's answer seemed like science fiction. What if the propeller could change its pitch automatically? What if a hydraulic system could adjust the blade angle in flight to keep the engine running at peak efficiency no matter the altitude or airspeed? It would be like giving every aircraft an infinite gearbox. The aviation industry reacted with predictable contempt. Hydraulic systems were heavy. Hydraulic systems leaked. Hydraulic systems added complexity and failure points. Why risk the entire aircraft on a fancy propeller when fixed pitch had worked for 20 years? Caldwell ignored them. He filled Hamilton Standard's workshops with prototypes, pistons, and oil pressure systems. His engineers thought he was insane. They were machining parts to tolerances tighter than anything in aviation. They were building governors that could sense engine RPM and adjust blade pitch within seconds. It was watchmaker precision applied to a piece of spinning metal 4 feet wide, travelling hundreds of miles per hour. One mistake, one imbalance, one failure, and the propeller would tear itself apart and take the aircraft with it. Caldwell spent 3 years testing, failing, and refining. Blades snapped. Hydraulic seals burst. Governors malfunctioned. His team worked 16-hour days. Every test flight was a gamble, but Caldwell had done the mathematics. He knew it would work. He just had to make reality catch up to the equations. By 1932, he had built a 2-position controllable pitch propeller. It wasn't fully automatic yet, but it could switch between 2 blade angles. One for takeoff and climb, one for cruising. It was crude, it was heavy, but it worked. Now he needed someone to prove it. Enter the Boeing Model 247. In 1933, it was the most advanced airliner in the world. Sleek, all metal, with retractable landing gear and twin engines. United Airlines bought a fleet of them for transcontinental service. There was just one problem. The Rocky Mountains, the Boeing 247, with its fixed-pitch propellers, could barely reach 6,000 feet. Pilots had to navigate through mountain passes praying the weather held. It was dangerous, it was slow, and it was humiliating. United Airlines was desperate. Boeing was out of ideas. Then someone remembered the crazy engineer at Hamilton Standard, the one who kept talking about hydraulic propellers. Caldwell was invited to demonstrate his system. He arrived with his 2-position propeller and a team of mechanics. The Boeing engineers were skeptical. They watched as Caldwell's crew removed the fixed-pitch propellers and installed the new hydraulic units. The system looked like a nightmare. Hoses, valves, governors, oil lines staking through the hub. One engineer muttered that it looked like a plumber had attacked the aircraft. Caldwell said nothing. He simply waited for the test flight. The pilot climbed into the cockpit. The engines roared to life. The Boeing 247 rolled down the runway and lifted into the air. At low altitude, the propeller blades were set to fine pitch, clawing through dense air with maximum bite. The aircraft climbed faster than it ever had before. Then, as the plane leveled off for cruising, the pilot flipped a switch. Hydraulic pressure flooded the propeller hub. The blades rotated smoothly to a coarse pitch angle, optimized for high-speed flight. The aircraft surged forward. The engines, no longer screaming at maximum RPM, settled into a smooth, efficient hum. Fuel consumption dropped. Speed increased. The Boeing 247 roared over the Rocky Mountains without breaking a sweat. When the pilot landed, he was grinning. He told the engineers that it felt like someone had bolted on a new pair of engines. United Airlines ordered the hydraulic propellers for their entire fleet. Boeing made them standard equipment. Within months, every major aircraft manufacturer in America was calling Hamilton Standard. Caldwell had done it. He had turned the propeller from a carved piece of wood into a precision instrument. In 1933, the Collier Trophy, the most prestigious award in American aviation, was awarded to Hamilton Standard Aircraft Propeller Company, with particular credit to Frank W. Caldwell, chief engineer, for development of a controllable pitch propeller. President Franklin D. Roosevelt invited Caldwell to the White House and congratulated him personally in the Oval Office. It was Vindication. But Caldwell wasn't finished. The 2-position propeller was just the beginning. He wanted full automation. He wanted a propeller that could sense engine RPM and adjust blade pitch continuously without any input from the pilot. He wanted a constant speed propeller, one that would keep the engine running at optimal RPM no matter what the aircraft was doing. Climbing, diving, cruising, accelerating. The propeller would handle it all. His team told him it was impossible. The mechanical complexity was too great. The hydraulic pressures required were too high. The system would be too heavy and too unreliable for combat or commercial use. Caldwell's response was simple: make it work. By 1938, After 5 more years of brutal testing, Hamilton Standard unveiled the Hydromatic constant speed propeller. It was a mechanical masterpiece, a hydraulic piston inside the hub actuated by engine oil pressure. A governor that sensed engine RPM and commanded blade angle changes in real time. A feathering mechanism that could streamline the blades on a failed engine, reducing drag and saving the aircraft. And most revolutionary of all, it was fully automatic. The pilot set a desired engine RPM. The propeller did the rest. During takeoff, the blades twisted to fine pitch, allowing the engine to spin faster and produce maximum power. As the aircraft accelerated, the blades gradually rotated to coarser angles, maintaining constant RPM and preventing the engine from overspeeding. During a dive, the blades adjusted instantly to keep the engine from tearing itself apart. If an engine failed, the pilot could feather the propeller, turning the blade's edge onto the wind and eliminating the drag that would otherwise force the aircraft into a deadly spin. It was a revolution. The Hydromatic propeller transformed aircraft performance in every measurable way. Takeoff distances shrank by 40%. Climb rates increased by 50%. Cruise speeds jumped by 30 miles per hour. Fuel efficiency improved dramatically. And perhaps most importantly, aircraft became safer. Feathering propellers on multi-engine aircraft turned engine failures from death sentences into manageable emergencies. The aviation world finally understood what Caldwell had been trying to tell them for 20 years. The propeller wasn't just a spinning blade. It was the critical link between engine power and flight performance. Optimizing that link didn't just improve airplanes, it transformed them. By 1939, every major aircraft manufacturer in America was installing Hydromatic propellers. Douglas, Lockheed, Curtiss, North American, Boeing, and just in time, because war was coming, and Frank Caldwell's invention was about to change the outcome. When Germany invaded Poland in September 1939, the Luftwaffe had the most advanced air force in the world. Their Messerschmitt 109 fighters dominated the skies. Their Junkers 87 Stuka dive bombers terrorized ground forces. Their tactics, their training and their equipment were superior to anything the Allies could field. But they had one critical weakness: their propellers. German engineers had focused on mechanical variable pitch systems, complicated gears and linkages that pilots had to adjust manually. It was slow, it was unreliable, and in the chaos of combat, pilots often forgot to adjust pitch at all, leaving their engines screaming at inefficient RPM and wasting fuel. Meanwhile, every British Hurricane and Spitfire rolling off the assembly lines was equipped with constant speed propellers licensed from Hamilton Standard. The British had recognised Caldwell's genius before the war began. They paid for the technology and installed it on every frontline aircraft. The difference was staggering. In the Battle of Britain during the summer of 1940, German pilots were shocked. British fighters climbed faster than intelligence reports said they could. They accelerated quicker in dives. They could dogfight at higher altitudes without losing power. Luftwaffe pilots reported that British aircraft seemed to have more powerful engines. They didn't. They just had better propellers. German engineers eventually realized their mistake and scrambled to develop hydraulic constant speed systems, but by then it was too late. The technological gap had cost them air superiority over Britain, and the advantage was about to get worse. When the United States entered the war in December 1941, Hamilton Standard became the beating heart of American air power. The military ordered propellers by the tens of thousands. Hamilton Standard's factories in Connecticut ran 24 hours a day, but even that wasn't enough. The military demanded more, so Hamilton Standard licensed their Hydromatic design to 3 companies that had nothing to do with aviation: Frigidaire, Nash Kelvinator, Remington Rand. Refrigerator manufacturers and office equipment makers were suddenly building the most advanced aircraft propellers in the world. It was absurd, it was brilliant, and it worked. By the end of the war, Hamilton Standard and its licensees had produced 530,135 Hydromatic propeller assemblies, more than 500,000. Virtually every frontline American aircraft flew with Caldwell's invention. The P-51 Mustang, the fighter that escorted bombers deep into Germany and broke the Luftwaffe's back, used more Hydromatic propellers. The B-17 Flying Fortress and the B-24 Liberator, the bombers that turned German cities to rubble, used Hydromatic propellers. The P-47 Thunderbolt, the P-38 Lightning, the F-4U Corsair, all Hydromatic. Even the British Royal Air Force, despite having their own propeller manufacturers, equipped a significant majority of their aircraft with Hydromatic units. Frank Caldwell's invention had become the standard for the entire Allied Air Force, but the impact went beyond performance. It saved lives. Multi-engine bombers like the B-17 often took brutal damage over enemy territory. Engines were shot out by flak, fuel lines were severed, oil systems ruptured. Without feathering propellers, a dead engine became a giant air brake. The spinning blades created so much drag that the aircraft would slow down, lose altitude, and become easy prey for enemy fighters. With Hydromatic propellers, pilots could feather the dead engine instantly. The blades would rotate edge onto the wind, and the drag would vanish. Crippled bombers could limp home on remaining engines. Crews survived missions that would have been impossible just a few years earlier. Hamilton Standard estimated that feathering propellers saved thousands of Allied airmen during the war. Frank Caldwell had not only destroyed Germany's air superiority, he had given Allied pilots a chance to come home. The Germans tried to catch up. By 1943, they were installing their own hydraulic constant-speed propellers on late-model Messerschmitts and Fokker-Wolf fighters. But the damage was done. The Luftwaffe had lost too many experienced pilots. Allied air superiority was total. American and British bombers flew in daylight formations, protected by fighters that could outclimb, outturn, and outlast anything Germany could send against them. German industry, already crippled by Allied bombing, couldn't produce enough advanced propellers to make a difference. The technological gap that Frank Caldwell had created in the 1930s had become an unbridgeable chasm by 1944. When Allied forces stormed the beaches of Normandy on June 6, 1944, they did so under the protection of complete air superiority. German fighters barely appeared. The Luftwaffe, once the most feared air force in the world, had been reduced to scattered remnants hiding from swarms of Allied aircraft. Every one of those Allied planes carried the fingerprint of Frank Caldwell's genius. The spinning blades that roared over the beaches, protecting soldiers as they stormed fortified positions, were the same blades Caldwell had spent 2 decades perfecting. After the war, Frank Caldwell returned to Connecticut. There were no parades, no ticker-tape celebrations. He was an engineer, not a general. The public had never heard of him. They knew the names of fighter aces and bomber pilots. They knew Eisenhower and Patton, but the man whose invention had made Allied air power possible remained anonymous. Caldwell didn't mind. He had never sought fame. He had sought perfection, and he had achieved it. Hamilton Standard continued to dominate the propeller industry for decades. Caldwell's Hydromatic design was refined and improved, but the core principle remained unchanged. Hydraulic actuation, constant speed governors, automatic pitch control, feathering capability. Every modern propeller aircraft, from cargo planes to turboprops, traces its lineage directly to Frank Caldwell's work in the 1930s. Even as jet engines began to replace propellers in military aviation, Caldwell's principles lived on. Turboprop engines, which used jet turbines to spin propellers, relied entirely on constant speed technology. Helicopters used variable pitch rotors, a direct descendant of Caldwell's hydraulic systems. Frank Caldwell worked quietly at Hamilton Standard until his retirement. He continued to refine propeller designs, mentor young engineers, and push the boundaries of what was possible. He believed that engineering was not about inspiration or genius. It was about persistence, measurement, testing, failing, learning, and trying again until the mathematics and the metal agreed. He once told a young engineer that the difference between a good propeller and a great propeller was 1,000 hours of testing and a willingness to throw away designs that almost worked. Caldwell never threw away a design that almost worked. He kept testing until it worked perfectly. That obsession, that refusal to accept good enough, had changed the course of history. In 1974, Frank Caldwell died at the age of 85. His obituary in the New York Times was 3 paragraphs long. It mentioned the Collier Trophy and his work at Hamilton Standard. It did not mention that his invention had helped win the Second World War. It did not mention that he had destroyed Germany's air superiority with mathematics and hydraulic pressure. It did not mention that 500,000 propellers bearing his design had carried the Allies to victory. But the engineers knew, the pilots knew, and anyone who has ever flown in a propeller aircraft, whether they realize it or not, has trusted their life to Frank Caldwell's genius. Today, if you walk through the Smithsonian National Air and Space Museum, you can see a Hamilton Standard Hydromatic propeller on display. It looks simple, 3 blades, a central hub, polished metal. But if you look closely, you can see the hydraulic lines, the governor mechanism, the feathering actuator. You can see 2 decades of frustration, testing, and refusal to give up. You can see the mind of a man who understood that progress doesn't come from building bigger engines or sleeker airframes. Progress comes from optimizing the invisible interfaces, the connections, the systems that everyone else ignores. Frank Caldwell saw a propeller and saw an opportunity. The aviation industry saw a propeller and saw carved wood. Caldwell was right. And because he was right, the skies over Europe in 1944 were filled with Allied aircraft flying higher, faster, and more efficiently than anything Germany could field. The Luftwaffe had started the war with air superiority. They ended it hiding in forests and praying that the roar overhead would pass them near. That roar was the sound of Frank Caldwell's legacy. The constant hum of engines running at perfect RPM, the smooth acceleration of propellers adjusting pitch automatically, the quiet confidence of pilots who knew that if an engine failed, they could feather the blades and fly home. Germany's air superiority didn't die in a dogfight. It died in a laboratory in Connecticut, killed by an engineer armed with hydraulic pressure and 20 years of patience. Frank Caldwell, the genius who destroyed Germany's air superiority, 1 blade angle at a time.